Our new goal, now that we've learned about circles, is to talk about just parts of circles. And what those parts of circles are called are arcs. So, what's an arc and how do we make one? That's kind of the goal of what we're going to be talking about next. So, uh, if I have a circle, and so this is all best going to be done just by kind of like looking at a diagram. That's not a color I like, nor was it a good circle. So let me try again. So if I have a circle, the first thing that I'm going to do is talk about, well, what if I just section off a portion of this? So what I have first is what's called a central angle of a circle. It's just an angle whose vertex is the center of the circle. So this point right here, which is my center, I'll call this O like I typically do. And so if I have an angle whose vertex is the center, what I've created here what's called a central angle. I'm going to label these points as well. So this angle right here is my central angle. So maybe I'll label that right here. This is my central angle. That's all there is to it. Another way of defining this is also it's an angle whose sides contain radii of the circle is another way of thinking about the same thing. So the angle itself isn't really the interesting part. The interesting part then is what gets created, which is the minor arc. So the minor arc of a circle is just the points on the circle lie in the interior of the central angle. So what I'm talking about here is specifically these points right here. Maybe that wasn't the best color to choose. I don't feel like that really made it stand out. But these points right here, this is my minor arc. My minor arc. And what my minor arc is, or let me actually say how I name it, is by using the endpoints. So I think that these are kind of like the segments of circles, really, ignoring chords, of course. But I talk about my two endpoints. They're A and B. And then this is the symbol that I use on top of it. So this is arc AB. Arc AB starts in A and goes to B. And it's just like we said, all the points are in the interior of the central angle here. So kind of the weird thing about this, and the reason we call it a minor arc, is because whenever we first started talking about angles, as of right now, all we know angles to be are just the angles whose measures are less than 180 degrees. And so a minor arc will always be the smaller portion, because you could obviously see here that I'm going to end up having two arcs. I'm going to have this one, but I'm also going to have this one, which is the major arc. So the major arc goes around the other side, and it's all the points that are not on the interior of my central angle then. So this is my major arc. And so the obvious issue, as you can see here, is like, well, what if I want to name this? How would I refer to it? And the answer is, well, I need another point here. We'll call this C. And so how I name this is by, I actually have to use 3 points. So the major arc is arc ACB. The reason for this is that whenever I just use 2 points, like I did over here for arc AB, I'm going to assume that's the minor arc. It's the smaller of the two. If I want to refer to the major arc, in this case arc ACB, then I have to give a third point. Now, could I name my minor arc if I knew another point over here? Let's say this point was point, what am I on, D. Could I also refer to this as arc ADB? Absolutely, I could. I kind of think of this as like whenever we were initially naming angles, and to give the full name for an angle, we could just call something angle A if it was non-ambiguous, or we could refer to it as angle BAC, for example, to give it its full name. It's kind of the same thing here, is that AB will always be the minor arc, and then if I want to refer to a major arc, I have to use 3 points, or I can refer to the minor arc using use 3 points as well, just to clarify things if I really, really want to. So the big difference between these then is, the larger or smaller parts of the circle. And we'll talk about how we measure these here in a second. But one last thing to add is that what a semicircle is just an arc with endpoints on a diameter, so half of a circle then. So how do we actually talk about the measures of these? And it all works out nicely because the measures of these these arcs is the same as the angle that creates them, same as the central angle. So let's say that I said that the measure of angle AOB is, let's say, I don't know, that looks to be about 80 degrees. Then I can say that the measure of arc AB is also 80 degrees. And so the major arc then, the measure of my major arc, so ACB, would be, well, we know what all of these add up to be. One trip around the circle is 360 degrees, and so what I'm left with here is 280 degrees is what the measure of my major arc here is. So I talk about measures of arcs just like I do angles, where I'm talking about them in degrees. And the reason for that is because they just correspond with the central angle that creates them. The one last thing that we'll point out then, of course, is that a semicircle, its measure will always be 180 degrees. The measure of the arc will be 180 degrees. All right, so that's how I create arcs, is how I name arcs, and that's how I talk about the measures of them. The last thing that I can do with these arcs and these measures is to talk about, well, can I talk about one being congruent to another? And so that's our next part. So we need something actually before I talk about that, and that is what it means to have two circles that are congruent to each other. So congruent circles are just circles that have congruent radii. Okay, so they have the same measure, they're the same size. That's all I need. It's a lot less complex than I need to do with polygons, for example, because there's only one way to create a circle. It's just the set of all the points that are equidistant from a given one, so my only real measurement there is the measure of that radius. So if I have two circles that are congruent, or sorry, two circles that have the same radii, they will be congruent to each other. Let's see if I can draw two circles that are even fairly, okay, cool. So then when I want to talk about congruent arcs then, are congruent if they have the same measure, but it's not enough just to have the same measure, because let's look at a really obvious example here. So let's say I create let's just make a really easy one. So this is the center, this is the center, this is the center. So I could create two arcs that are both 90 degrees. So this is a 90-degree arc, and this is a 90-degree arc. Maybe I should label some things, A, B, and C, D, E, and F. And then we'll make one more, just so that we're consistent, D, E, F, G, H, and I. And this is also 90 degrees. So what I can say here is that, let's see, so arc AC is congruent to, so same congruence as before, to arc GI, that I wrote GH, darn. And the reason for that is because their radii are congruent. And so if we were actually to take a tape measure of these and measure how big these arcs would be, we see that they would be the same length. Now, we're not going to. We'll talk about arc lengths later on, but they'd be the same length. However, in this circle E over here, this arc is obviously not going to be the same length because it's part of a bigger circle. It has the same measure, but it's part of a bigger circle. And so these two arcs, and so this would be the third one, DF, will not be congruent to the other two because is not of a congruent or the same circle. So that's what I need for congruent arcs, is that they're of circles that have the same, they have the same measure, and then they are of the same or congruent circles. It just needs that additional criteria is all. So that's everything we need to know right now about arcs, just talking about these portions of circles, and so we can use this information later and build off of it.